this episode, we shift from thinking about single AI risks in isolation to thinking about how an organization can handle many AI risks in a repeatable way that does not start from scratch every time. Beginners often picture controls as a one-time fix, like plugging a leak and moving on, but AI systems change quickly, and the same kinds of problems show up across very different projects. A control library is a way to turn lessons learned into reusable patterns, so teams can move faster without getting sloppy. The key idea is that you are not inventing brand new safeguards for every new model, dataset, or use case, because that approach burns time and increases inconsistency. By the end of this lesson, you should understand what a control library is, why it matters for AI risk, and how to design one that stays practical instead of becoming a dusty document. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A control library is a curated set of control statements, checks, and expectations that can be applied repeatedly, with small adjustments, across many AI-related efforts. In plain language, it is a menu of safeguards that people can choose from based on what they are building, rather than improvising safeguards every time. It usually includes both preventive controls, which reduce the chance of a problem, and detective controls, which help you notice problems quickly if they happen anyway. It can also include corrective controls, which define how to respond and recover when an issue is found. The library should be written in a way that is understandable to non-engineers, because governance and risk decisions are not only technical decisions. When done well, it becomes a shared language that helps teams talk about safety and accountability without needing to argue about basic definitions each time. To design a useful control library, you need to understand what makes AI different from many traditional technology systems. With AI, the behavior of the system often depends heavily on data, context, and user interaction, not just fixed rules. Outputs can vary even when inputs look similar, and models can drift over time as the world changes or as data patterns shift. People can also misuse AI in unexpected ways, such as treating suggestions as facts or relying on a confident-sounding answer even when it is wrong. Because of that, AI controls often need to address not only the model itself, but also the data supply chain, the human use of outputs, and the lifecycle of monitoring and updates. A library that focuses only on the model and ignores how outputs are used will miss many of the real risks that show up in day-to-day operations. A good way to begin is to group controls by what they are trying to protect, rather than by what team performs them. You can think of broad categories like data protection, model quality, fairness and harm reduction, transparency and traceability, security and access control, and operational resilience. These categories help you avoid a library that is just a random pile of rules, because the library needs to be navigable. Even though you will not use headings inside a formal library document in every context, the mental grouping still matters for design. When a new use case shows up, like a chatbot, a decision support tool, or a forecasting model, you can scan the library categories and pull controls that fit the risk profile. This is how the library becomes reusable, because it is organized around needs rather than around one specific project. The phrase reusable patterns across use cases is important because it tells you what not to do. You should avoid controls that are so specific that only one team can apply them, like controls that mention a particular vendor feature, a specific internal tool, or a single technical approach. Those controls will age badly, and they will not transfer. Instead, aim for control language that expresses an outcome and a requirement, leaving room for different implementations. For example, rather than saying a team must use a certain monitoring platform, a reusable control could require that model performance and key failure indicators are monitored and reviewed on a defined schedule. That keeps the control stable even if the organization changes tools or architectures. Reusability is about focusing on what must be true, not on exactly how it is made true. To keep controls from becoming vague or toothless, each control should answer a few basic questions in plain language. What risk does this control reduce, and what harm is it trying to prevent? What does compliance look like in observable terms, so someone can tell whether it is being done? Who is responsible for making it happen, so it does not become everybody's job and therefore nobody's job? When does it apply, so teams do not argue about whether it matters for a small pilot or a major deployment? Controls that cannot be observed or tested tend to turn into box checking because people can claim they followed them without proving anything. Controls that are clear about evidence and responsibility are more likely to lead to real behavior change. A strong control library also recognizes that not all AI use cases are equally risky, so the library should support scaling. One way to think about scaling is to build controls that come in tiers, where basic controls apply to almost everything and enhanced controls apply to higher risk situations. Basic controls might include having a clear purpose statement, identifying the owner, documenting data sources, and setting acceptable use expectations. Enhanced controls might include deeper evaluation for fairness, stricter privacy protections, higher scrutiny for safety impacts, and stronger review before deployment. The point is not to make life hard for low-risk experimentation, but to ensure that high-impact use cases get the attention they deserve. Without scaling, teams either ignore controls because they are too heavy or they deploy risky systems with the same light oversight used for harmless prototypes. It also helps to design the library around the AI lifecycle because controls need to exist before, during, and after deployment. Before deployment, you need controls that address data selection, model selection, and validation against intended use. During deployment, you need controls that address access management, user guidance, and logging for traceability. After deployment, you need controls that address monitoring, incident response, and change management when models are updated or behavior shifts. Beginners sometimes assume that if you tested a model once, you are done, but real systems live in changing environments. A good library makes it normal to revisit assumptions and measurements, because that is how risk stays managed over time. This lifecycle thinking also supports reuse, because every AI project has a beginning, middle, and ongoing operation, even if the details differ. Another important design idea is to connect controls to common AI risk themes so people can quickly understand why the control exists. For example, many use cases share risks like data leakage, hallucinated outputs, over-reliance by users, bias in outcomes, or lack of traceability when something goes wrong. If your library includes a short description of the risk theme each control addresses, it becomes easier to choose the right controls without needing a deep technical background. That risk connection also prevents the library from becoming a compliance artifact that nobody understands. People are more likely to follow a control when they understand the harm it prevents, because it feels like a safety practice rather than a random rule. This is especially important for new learners, because understanding the why is what builds real judgment. To make the library practical, you should include patterns that address human behavior, not only system behavior. For example, one reusable pattern is to require clear user disclosure and guidance about what the AI can and cannot do, because that reduces misuse. Another pattern is to require a human accountability point when AI influences a decision with real consequences, because that prevents blind automation. You can also include patterns that require review for high-stakes outputs, such as requiring a second pair of eyes for certain categories of content or decisions. These are not about technical perfection. They are about aligning the system with how people actually work. Many AI failures happen because humans assume the system is more reliable than it is, so controls that shape expectations are often among the most valuable. A control library should also include patterns for traceability and learning, because risk management improves when you can look back and understand what happened. Traceability does not mean collecting everything forever, but it does mean capturing enough information to explain why a system behaved a certain way and how it was governed. Reusable patterns here include documenting model purpose, documenting data lineage at a high level, and recording major decisions about deployment and change. Another pattern is to define what triggers a review, such as a spike in complaints, a drift in performance, or a change in the environment that invalidates previous assumptions. When these patterns are in the library, teams do not need to invent them under stress after something goes wrong. They can follow an established playbook that has already been agreed upon. It is easy for a control library to become too large and too abstract, so part of the design is deciding what to leave out. You do not need to include every possible control idea, especially if it is unlikely to be used or if it requires specialized context that only a few people understand. A library that tries to cover everything becomes unusable because no one can find what they need and teams stop engaging. Instead, focus on high-leverage controls that address common risks and that can be applied broadly. You can also include a small number of specialized controls for high-risk areas, but those should be clearly tied to conditions that make them relevant. The goal is to create a library that people actually use, not a library that looks impressive on paper. Once you have a draft library, the next challenge is making it easy to apply across different use cases without constant negotiation. A simple approach is to map controls to use case types, such as generative content creation, decision support, automated decisioning, monitoring and detection, or personalization. Each use case type tends to trigger certain risk themes, so you can recommend a default set of controls for each type. This does not remove human judgment, but it speeds up early decisions by giving teams a starting point that is already risk-informed. Over time, you can refine those mappings based on real outcomes, such as incidents, near misses, or audits. This feedback loop is what keeps the library alive and improving instead of stagnant. The most important point to remember is that a control library is not only a document, it is a social agreement about how the organization behaves around AI. The library sets expectations for consistency, but it must also allow flexibility so teams can innovate while staying safe. If the library is written like a set of punishments, people will hide projects and create shadow processes, which increases risk. If the library is written like a set of practical guardrails, people will use it because it helps them move faster with fewer surprises. Good libraries are updated regularly, use language that a beginner can understand, and remain focused on outcomes that matter. When you build controls as reusable patterns instead of one-off fixes, you create a foundation for AI governance that scales, and you reduce the chaos that comes from treating every new use case as a brand new problem.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.